Well, number 35. Let's take a look at this. So I have this segment congruent to this segment, congruent to this segment. That's pretty good. That's nice. Let me move this. Okay, so what does that mean? I don't know. But it looks like 18, this part, this is 18. And so I need to know what this is. Well, maybe if I figure out one of these tick marks, then that will give me that side. So I'm looking at a couple different triangles. There's a big one. There's a small one. It's not a right triangle, so I can't use Pythagorean theorem. This is a right triangle. This is a right triangle. It's because that is also 90 degrees. But look at this. This thing, that big, or medium, I guess, medium triangle is something that we can use. So we have 18. I'm drawing this triangle. So that's 30 there. And then this comes down. It's a segment bisector. And makes that congruent to that. So if I find this whole length, then I can cut it in half. And then I will have found the individual tick marks, which means I can work on that. So that's what I will do. I will find this, call this the question mark. So this will be my A, B, and C. C is always the longest. This is a right angle. So question mark squared plus 18 squared and equals 30 squared, equals 30 squared. So then I have, what here? I don't need to show that. Question mark squared plus 18 squared, what is that? That's 324 equals 30 times 30 is 900, I believe. Of course. Subtract 324. So whatever I have squared, this side length is going to equal 324, 576. And I will square root both sides. Maybe that's a perfect square. I don't know. Answer 24. It is a perfect square. So the question mark equals 24. That means that is 24, which means these are each 12. So 12, 12, 12. Now I'm ready to solve for x because I have a new triangle. That's 12, 18, and x. So 12 squared, I'm going to say this is A, B, and C. 12 squared is 144 plus 18 squared. I don't know what that is. And x squared. So 12 squared plus 18. Well, what's 18 squared? Let's just show that. 18 squared. 324. Did I do that already? I did. 324. 144 equals x squared. Combine those. 468. That's x squared. And then square root both sides. So x equals the square root of, well, it doesn't go in evenly. It's 21.63333 something something something. So I'm gonna try and reduce this. 468. That's a big one, but I can still do it. So that's gonna be my answer, but in unreduced form. So I'm gonna try and reduce this here. 468. I know I can divide it by 2. 468 divided by 2. That's 234. I can divide it by 2 again. And that's 117,789. I can divide that by 3 by adding up the digits. 7, 8, 9. 9 is divisible by 3, so is 117. Divided by 3. That's 39. I know that's divisible by another 3. And that's 13, and 13 is a prime number. So I have a pair there and a pair there. So 2 squared times 3 squared times 13, all in the radical. When you have a square in the radical, the square will cancel with the square root. So you just have 2 times 3 on the outside, 13 on the inside. So that's 6. Can you see that? No. 2 times 3 on the outside, 13 on the inside. So that's 6 root 13. And if we check, just to make sure I did it right, the square root of 468, let's see what that gives us, 21.6 whatever. And then what if I did 6 times the square root of 13? I should get the same thing if I did this properly. And I did. So x equals that. That is number 35. Yay! Where's my mouse?